future dev legends. By the end of this video, you'll learn how to build a cool 2D, 3D hybrid site that scrolls nicely, keeps the 2D and 3D content aligned like this. We've even got a sort of subtle delay on the movement of the 3D, so it kind of catches up slowly. The 2D content text fades in and up as you enter, as does the 3D spheres. So at the top they're faded out, they come in to full opacity, then they fade back out again. So this animation work is done using gsap and gsap scroll trigger. The 3D scene is set up with React 3 Fiber, and all in all, we're talking about 350 lines of code for this entire page, including all the content. So it's quite lightweight. The code can be found in my public GitHub repo, Pragmatic Tutorials, so do check that out if you want to kind of base your own project off of that. That'd be cool. Do give me a thumbs up and consider subscribing. Let's dive into the code. All right, let's go. The 2D setup is where I shall begin. We're going to create the content for each section, map those to HTML elements, animate that content so we get a kind of sliding up fade in effect based on the scroll, and we will put in a progress bar along the bottom before moving on to the 3D. So let's start with creating the content for each section. I've defined a type for the section content. It's got a heading, a body, and a href optional. I prefer to use React Node as the type for heading and body. In this case, all of these are just strings, but if we wanted to say update this to have a bold element inside of it, we can, by using a React Node, then we can simply wrap a span, say around this, and that's still valid. So I can say class name text black, for example, font black. So yeah, this is just an array of section content, and these sections will be used to determine like the number of pages, basically. So yeah, there's a div inside the main, mapping those sections onto a section component, and we're spreading the content and adding the index. The section itself has section props which extend the section content, so heading, body, href, and with an index. So we've got access to these here. Basically created a section which is full width and screen height. I can put a border on that. It's also a grid with 6 grid columns, and we'll get to that a little bit later. But yeah, we can see here now we've got our full height section. The isOnLeft boolean is determined by the index, so alternate based on that, and then I'm using tailwind join here to conditionally add the classes for its position. So if it's on the left, we're going to start in column 2. If it's on the right, we're going to start in column 4, and each one will span 2 columns. If it's on the left, so the second block, we're also going to put its text to the right. I actually set that opacity 0. So yeah. This is quite a simple way to get kind of alternating text image or text content block setup. The href is optional, so I'm casting it to a boolean with the double exclamation mark here, and then if there is a href, inserting some line breaks with our anchor element. Remember to put rel no referrer, target blank, so that it opens it in another window. See, I legit bought this book ages ago, actually. What about this one? I did buy this. Yeah, some classics here. I say classics, 10 years ago. That's that really. I'm not going to spend too long talking about the tailwind. I think that's a topic for another video. Okay, so we've created the content, we've mapped that to our HTML sections. We can now animate the content on scroll. So if I return back to the section component, uncomment this, the use gsap hook is being used in place of use effect, and that is imported from gsap react. I'll list the dependencies at the top here before committing this code. The gsap system needs to register the scroll trigger and the use gsap plugin. So that is done at the top of the page. Now in here, we have a ref on our section. And this is a HTML div element. Section doesn't actually have its own type, which is odd, but HTML element or HTML div element both work there. The ref is then used as the scope for this effect, and what that means is that we can target our H2 and our paragraph by using this type of query selector, which means no need to put classes or identifiers on to these. So we've got this gsap tween is scope to the section. Then what we can say is we want to animate the heading and the paragraph from opacity 0 and Y48, so slightly down, to Y0 and opacity 1 with a middle keyframe in here. This is basically just saying that the Y movement will happen before the opacity change is finished. So we'll get to Y0 whilst the opacity is still at half. And this was just me fiddling around. We can change these values. The stagger inserts a kind of a delay between each of these so that the H2 will begin first because it will be in this order, and then it will wait 0.15 seconds. The duration is also defined here, as well as no easing. No easing is important because the scroll trigger here is actually determining the progress of the animation. It's not using time, it's using the scroll position. The scroll position is sort of set using our trigger element, and this is the div that I've wrapped around the text here. And that's, if I put a border on that as well, we can see what element that is. So that's this text block here. We could do it on the entire section, but the trouble with doing it on the full size section is that the section actually enters all the way down here. So you're not going to see any of this happening. And it's going to be harder to align the animation to where you want it. So what I've done is I put that in a div with the class name on it, .text. And because this is scoped, it will only find the div within the section of that ref. And then we're saying start when the text reaches the top of the text. So top of the text here reaches 90% of the viewport height. So that's around here. So now we'll see it starts to come in. We're ending it at center. So ending it right in the middle here. So at this point, that has finished and it's fully animated in. Yeah, so that's looking pretty clean. It's quite subtle, but it's nice to bring the eye to the text as it enters without it moving too much, which is why I've used a low Y translation value here. Finally, you need scrub set to true because this is telling gsap that we want to use the scroll to move through the animation as opposed to just triggering it on enter. So if I take scrub off and then go down, yeah, you'll see as it reaches 90%, it will just come in like that. And that's not bad. I mean, the duration and stuff looks a bit whack here. In fact, I might take off that. Obviously, if you were not scrubbing the value, then you'd probably want a nice ease on it. Okay, so that covers the 2D content animating on scroll. Okay, so let's add a scroll progress bar to indicate to the user where in the experience they are, how far through it they've scrolled. I'll put this progress bar in here. Progress bar is not part of the scrolling content and it will have a fixed position. We can play around with the actual kind of sizing of it. It would be nice if it was just, say, a small bar down here or potentially along the top. But for now, let's get the actual movement of it set up. So I'll set up another use gsap and we will simply, we want to transform the scale or the X position of this bar inside. Quite often developers animate the width or they set the width, but that's not best practice when it comes to animation. So what we want to do is actually scale or translate on the X the bar that's inside of the container. So we've got our container, which, say if we put background of green, we've got our bar, let's put a background of black. Yeah, let's make it really big for now so we can see it. So we can see our container here along the bottom, and the bar is not visible because it's initially got us an X scale of 0 with an origin of left, and that's because we want to scale it from its left side. If we don't have an origin on it, it will kind of move from the middle outwards. So now what we can do is progress bar, and we want to set its scale X to 1 with a scroll trigger that starts at the top and ends at the bottom and is scrubbed with an ease of none. So now we've got our progress bar. And that is working perfectly. In terms of design, I will tweak this a little bit, but I'm not going to spend time on it now. we'll just say make that white. Diving into the 3D setup, and let's face it, the reason you're probably here. So canvas from React 3 Fiber. Missing children. So I'll just attach a background color to it. No change. This is fixed. Inset 0, which is the same as top left, right, bottom 0. Few settings, and now an environment. So the environment will place this kind of background scene that wraps around the content within it. And I downloaded an image from here. So this site is quite an amazing resource for these HDRIs. And you can choose whatever you want, like night, moon. These are neat. And if you want it to actually appear in the background, you need to specify background to true. Otherwise, it will just be used for things such as reflections and lighting on other elements. You can define the blurriness. I played around with the figure here. And ground, we want to false because we're not placing elements on the floor in this scene. Now we've got our canvas lighting and environment set up. We'll add the ambient lighting here. The pointer camera is a nice way to kind of show off the fact that what you have is a 3D scene. So let's put that in and talk about the code. So the pointer camera component here is a perspective camera imported from React 3 Dre. It's made default. Has a position 5 on the Z, so it's kind of moving away from objects in the center, and some near and far values. The actual pointer influence is done by capturing the pointer inside a ref. So we have a window listener for pointer move. On pointer move, we can grab the X and Y, and using the size of the viewport, so this is the pixel size of the canvas, in fact, we can normalize that, and then we get an X and Y value. So I can log those. So over here we've got 0.5x, and over here we've got negative 0.5. Up here, negative 5y, positive 0.5, I mean down here. Then inside of the use frame hook from React 3 Fiber, we can mutate the camera position on the X and the Y. So we're taking its previous value and we're adding the previous value minus the camera, the pointer minus the camera position, and then multiplying it by a small value so that it has a kind of more subtle influence. But now you can see that the pointer is moving the camera. So this is pretty cool, looks decent, and it signals that we're in a 3D space. Onto the scrolling. There is a Dre helper scroll controls. And I've actually used this on kind of commercial project where we had a 3D scene of like dozens and dozens of images and text moving down, and we were using a different Z value to create a parallax effect. So if you've got a 3D scene, something that's further away will kind of move slower than the one that's in front of it, and that will give a nice sort of simple parallax. The scroll controls system can be set up by following the documentation here. Basically, it creates a scroll wrapper for the canvas contents that you want to scroll, and then it creates a scroll wrapper for the HTML contents that you want to scroll. And this is quite a simple way to do it. The only downside is that you have kind of limited control over how the system works. For example, if you wanted to scroll from top to bottom, from bottom to top, it becomes a little bit harder. Or if you wanted to say the 3D content to move in the opposite direction to the 2D content, again, you sort of need to write your own solution. So I looked into the code for the scroll and saw how that was working. The other advantage of the use scroll hook is that it can tell you where in the scroll, in your current scroll, what's in view. And it does so using these kind of range and visible functions, but you do need to pass in the kind of the range in which you want to test, and that can be a little bit confusing. So in the video here, I'm actually going to show you a different approach, which is simpler, but it kind of leverages the gsap animation framework to do some of the work for us. And I'll share a few of the benefits of that in a minute. So we've got a scrolling group. The scrolling group is a kind of a container for our sections or our pages. The height and the width of the viewport are used here. The page height is set to the height of the viewport, but we could say if we wanted to have each section taking up half of the display, then we could say page height divided by 2, and then we just adjust our sections in the HTML to follow that same sizing. So again, this approach of doing it manually means you can adjust the heights of your sections more easily. So we got a group, and the group is an array of the length of the sections, and then mapping into a page. And the scene page is really just a sphere, which has a reflective material attached to it. So what we want to do inside of the group is we want to translate its Y value, its Y position, based on the scroll. So again, we're using the scroll trigger with a start and end, start of 0 and end of max, with no easing. And we're then moving the group on its Y by the height of a single page times the number of sections minus 1. And so now you see that this tracks exactly to the scroll. What if we wanted to, say, change the direction? So if we wanted to, say, move the spheres up instead of down, we could change their position so that they are mapped in the other direction. So now we've got kind of this effect. It's sort of like they're falling down, which I actually quite like. So this is the sort of scroll trigger for the movement of the group. We can also specify an increased scrub value, which means that it will take 0.3 seconds to catch up. So now there's a slight delay. If I make it a lot higher, then I think it'll be clearer. So that's quite cool. Fast scroll end is just an optional property that says if a user really quickly scrolls to the bottom, that I want to ensure that the animation completes. So onto the actual scene page itself. These are inside the group. We're mapping those, and we've got the index passed in, section index, and the column width. The column width is determined by the width of the viewport. So remember, in the CSS, we have a grid, which is width full, column 6. I'm kind of replicating that in the threejs scene by dividing the width by 6 to get a single column width. And then that column width can be used, A, to kind of size things responsively, but B, position them correctly relative to the 2D content. So the column width is passed into the scene page along with its position. The position is, think about this, each page is basically positioned on top of one another. So as the index increases, the Y value of that page also increases. So it's like we're just putting them, stacking them on top of each other. And that's why it's multiplied by the index here and the page height, which we defined at the top. I'll put this here. So the position is set to the group. So we're actually talking about the group's position. The sphere's position alternates depending on the section index. So if it's on the left, we'll use this position, which is one column width to the left. It's this way. And then if it's on the right, it's one column width to the right. And this, I've done this quickly. I think there may be a couple of small issues with this, but just to illustrate kind of the use of the column width in the 3D scene to match up to the grid column itself. That's our sphere. We've got a standard, basic, well, an out-of-the-box material, I should say, with a color, and the color is just one of these values in the array. The color's actually passed in, but doesn't need to be passed in because we've got the index. So what if we wanted to animate the scrolling group, the element here, this sphere? We can leverage gsap to do this because we know we kind of have a corresponding section here, and we also have a corresponding text block here. So we know as this section here is entering, and as it's fully entered, this has aligned centrally, horizontally. So what we could do here is inside of our scene page, or our sort of section, 3D section, we could also use gsap to target the sphere. So if I put a ref on the sphere, in fact, I'm going to put a ref on the material itself, and then what we'll do is we'll animate its opacity. So we need to specify it as transparent true, start with 0 opacity. So they're all hidden now. But what we want to do is really fade them in as the corresponding section is entering. As I mentioned with scroll controls, if you're using the scroll controls tray system, you could do this by calculating the range between the start and end of scroll offset. So for example, this is 0 to 1 divided by however many sections there are, and this would be 2 divided by how many sections are, 3 divided by how many sections there are. I think that's the math for doing that, and yeah, you could work that out, but because we're using gsap, we can actually, instead of doing that, we can just base it essentially on the section itself, because each section in our HTML component has an index, and each of the scrolling pages also has a section index. So with that, we can say we want to animate the material's opacity based on the movement of that section through the viewport. So with that, let's say if we started at the top at the bottom, we ended at center. Now it's fading in. It seems to be, it is definitely more faded up there, but it doesn't seem to be particularly noticeable. Starting at the top of the bottom, so when the top of the section reaches the bottom, yeah, so that is definitely fading out to nothing at the top there. I think it's the easing again. If we wanted to fade it in and out, we could do that using some keyframes. So we want to end it now when if we wanted to do it like that, we'd say we end it when the bottom of the section reaches the top of the viewport. And then we can say keyframes. Yeah, so now it's fading out both sides. I'm not sure if I need that. We start at 0 opacity, then we move to 1 opacity, and then we move back. So I don't know if that one's actually needed or not. Let's try. Yes, that seems to be working. So you can see how using the gsap scroll trigger has made it quite easy for us to animate the 3 element based off of the scroll position of the 2D content. The fixed group is quite straightforward. It basically, we're just not translating that group. Anything that we want to move up and down like a page would need to be inside the group that has the Y translation applied to it. The fixed group is just some randomly positioned spheres. So by putting those in, we have a kind of an even more dynamic scene. They have a reduced opacity and smaller radius segments, or width segments, because they're further away. We don't need to make them as high fidelity or smooth. And then, yeah, just some positioning to kind of wrap them in a sort of oval back there. Cool, let me take off the borders and we can have another look at the final result. The code will be in the pragmattic tutorials repo. So if you want to kind of get started there, just check it out. You see here that the sphere scaled to the width of the viewport. Wouldn't necessarily always want to scale the element, but you might want to always ensure that its position is at least relative to the width of the viewport, and then the corresponding grid in CSS here. Cool, so yeah, we've got elements fading in and out as they enter. Got a slight kind of delay for it to catch up. We've got the text itself fading in with a slight Y translation as well. And finally, there's a progress bar along the bottom. So hope you learned something from this. Let me know if you've got any feedback or comments or questions. Consider giving this a thumbs up, especially if you got any value from it or the code itself. And yeah, hit that subscribe. Have a good day. Peace.